Hello, today's video is on point slope form, which if you are a calc student, an AP calculus student, this one is hugely important for you. The other classes, not as much, but still something that's useful. And the idea for point slope form is that when you don't have the y-intercept, but you have the slope, you can still write an equation. So again, this one's great for when you don't know the y-intercept, but you do have one individual point on a graph, and you do know the slope. All right. So again, the y is a missing number. Our x1 and y1 are the given point on the line. Our m is still our slope, which could be in fraction form, or as rise over run. And then the plane x is another missing number. So again, there's the generic version of the formula. And we're going to take a look at a sample of how we use it. So your work today will get about this difficult, where you are asked to write the point slope equation for the line through these 2 points. All right, so that means I need 2 pieces of information. I need a point, and they've given me 2 to choose from. So I'll just use this one. All right, I'll show you later on that you can use the second point as well. And then I'll need a slope. And I don't have the slope. They didn't give it to me. But they gave me enough information to actually find the slope. Again, if I consider this to be my x1, y1, and this to be my x2, y2, I could use that slope formula and do y2 minus y1 in the numerator, and x2 minus x1 in the denominator, and that will give me 2. That's going to act like a plus, and 3, 2/3. There's my slope. So now if I want to write the equation in point slope form, I will put in y minus, again there's always a minus in the formula, and then my y1 number, which comes from this point I've chosen, 3, and then equals my slope, 2/3, and x minus my x coordinate, -2, and when I minus a negative, it's going to act like a plus. All right, that is point slope form. Right, you do not need to convert it, anything else. It's fine the way it is. It's a little ugly. We could convert it, which I'm going to show you next in a moment. So what if I had used the other point? What if I had used the point 1 and 5? Now, I would have still had the same slope, 2/3. But when I wrote the equation, it would have been y minus y1 coordinate 5 equals slope of 2/3 and x minus the x1 coordinate of 1. All right, those look very different, but they are the same equation. All right, if I simplify them, which again, you do not have to do this today. You do not need to convert it into slope-intercept. But if I did that, if I multiplied out these parentheses, I'd get 2/3 x, and then 2/3 times 2 makes 4/3. And then I would want to add 3 on both sides to get this into slope-intercept form. And that would give me 2/3 x, and then 4/3 plus 3, I'd make the 3 into a common denominator, 9/3, that would give me 13/3. Not pretty. Now if I'd done the same thing on the other one and multiplied out the distributive property, it would have given me 2/3 x, and then 2/3 times -1 is -2/3. Then I would add 5 on both sides. And again, I'm going to have to convert that 5 into a common denominator with this 3. 15/3 is the same as 5. And if I do -2 plus 15, that gets me 13/3. Oh, they are the same. They just don't look the same in the beginning because I've chosen a different point. But once again, you do not need to do that last part. You may stop here. I just wanted you to see that these 2 answers were actually equal to each other, even though they do not look equal right now. But again, if you simplified them, they are the same. All right, so that's the gist of your work today. Hopefully this is something that is drawing a bell, or ringing a bell for you, because again, especially calculus, this is going to be an extremely important formula for us to use. All right, have a great day.